right, we are going to review here for your Unit 2 quiz on activities 7 through 9. So, again, can't do every problem. This will be long no matter what, but we'll just pick at least, one of each major concept to cover. So, when we are looking at Lesson 7.1, we needed to pick out something that was really important. We did a ton of given this perimeter or given this picture where one of the sides of the barn was a side of your fence, coming up with functions that represented the area. And in order to write those expressions for the area, we had to come up with expressions to represent the other side lengths. So I think number one's pretty self-explanatory, coming up with the dimensions and the area. So the one that I listed on the answer sheet, again, is just one example. You had to have at least 3, so I did the 5 by 15. Certainly you could have done 10 by 10, 13 by 7, anything where when you added the perimeter up, it gave you 40, would be fine for the dimensions. So number 2, a lot of people had questions on, and this is identical to what we did in Lesson 7.1. So if you need to flip back there, that would be a good resource for you. But in Lesson 7.1, we had a rectangle with a perimeter of 100. And what we had said, because we had drawn this picture, and we said, well, if we have a rectangle, that means I've got 2 lengths, 2 widths, because opposite sides are congruent. And so the perimeter would be 2w plus 2l. And so, in the one we did in class, when we had a perimeter of 100, that meant that the length and width added to 50. Here, our perimeter is 40. So you can see here, if I were to divide both sides by 2, that means that the width plus the length, in this case, should equal 20. Now, you should know that, because what we said in class, because we did at least 3 different situations like this, was that as long as you have all 4 sides, the length and the width of a rectangle should always add up to half the perimeter. So here the perimeter was 40, so they added to 20. Now, you may want to go back and look at the example we did in class where we had the side of the barn as one of the fence sides, because if you look at your embedded assessment, it's set up similar to that. So I would definitely suggest going back to look at that as well. But in this problem, the length plus the width has to equal 20. So in number 2, it wanted you to write an expression for the area. So we know that area is length times width. But when we're writing a function, a of x, that means a is one of my variables, which stands for area, and x is my other. And in the question, in its directions, it told you to make x the length. So if x is my length, then my width, if I look here, back over here, my width has to be 20 minus the length, because I would just subtract the length from both sides. So in this case, 20 minus x. So that is how I came up with my answer in number 2. I had put or equivalent because if you multiplied this out by distributing, certainly that answer would be acceptable as well. 3 is to graph it, and again, notice on my answers that I have labeled the axes. I've given the graph a title. There's a scale. Make sure that you keep in mind all of those things when you are drawing graphs. Numbers 4 and 5 give you area values and want you to show algebraically and graphically why the answer is the answer. So I'm only going to do one of those. The other you can do in a similar way. But number 5 gave you an area of 120. It told you that it's not possible and wanted you to write out why. So if you take your area function up here and we plug in 120 for the area, that's what we would do to solve this algebraically. So I plugged in 120. I distribute here, so I've got 120 equals 20x minus x squared. I put it in standard form, so I move my x squared over, I move my 20x over, so I end up with x squared minus 20x plus 120 equals 0. Now, when I want to solve this, I cannot factor it because there's nothing that multiplies to a positive 120 and adds to a negative 20. But because my a value is 1 and my b value is even, the easiest way is to complete the square. You could also use the quadratic formula here if you wanted. So I completed the square, so I did x squared minus 20x plus blank equals, and I had moved this 120 over to the other side and added here. Now the value that completes the square, remember, is always b divided by 2 squared. So 20 divided by 2 is 10, squared is 100. So the value that completes the square is 100. So this is x minus 10 squared equals negative 120. So if I solve that by taking square roots, x minus 10 equals plus and minus. Radical 20 simplifies to 2 radical 5, and because it's negative, I have the I. So plus and minus 2i radical 5. And then I would need to add 10 on both sides. So I end up with x equals 10 plus or minus 2i radical 5. Now, what it had asked you to do is to verify algebraically that this area of 120 isn't possible. So by solving it, I see that this isn't possible because I have i's. This is no real solution. Now, if you didn't solve it to completion, if you just stopped and said, I know because I'm taking the square root of a negative that these are imaginary solutions, which means there is no real solution, that would be okay as well. As far as describing graphically, remember that the graph looked something like this. You can see it on your answer sheet. But if you look at it, the maximum value on the area is at 100. So an area of 120 isn't possible because it's above the max. So that's what you would say as far as the graphic explanation. Again, number 4 is the same thing, except you put in 96 instead of 120. And that one is factorable, is solvable, so you can actually get answers to go with the dimensions there. Number 6, listing domain and range. I'm not going to go over all the forms because they're on there, but remember that for domain, you look to the left, you look to the right. These ones do not have arrows because it's real life. It doesn't go on forever. So the lowest x that I have is 0. The highest x value that I have is 20. This is the exact same thing. Again, if you flip through your lesson 7.1, we answered the domain and range questions for a parabola that looked very similar to this. So there is a good resource for you to go back and look, but we said it doesn't include 0 and it doesn't include 20 because if you actually had a length of 0, there wouldn't be a rectangle. So it doesn't make sense. Same thing if you had a length of 20, that would force the width to be 0, which means there is no rectangle at all. So that is why the 20 and the 0 are not included on the domain. On the range, 100, which is the max y value, because again on range, we look down, the lowest point is 0, which is not included because you can't have an area of nothing. When I look up, there's a stopping point when y is 100. The 100 is included because there are dimensions that give me an area of exactly 100. All right, I think that's enough on section 7.1. Now moving on, the next couple that you had were factoring problems, and you can see the answers for all of them. Again, I can't work out all of the factoring problems again. If you are still having a lot of trouble factoring, remember, there are 2 videos on my YouTube channel and linked to my website that have factoring explanations on them, and certainly you can find a million other videos out there for short factoring explanations as well. The one I would like to look at two of the factoring problems that were assigned. So I'm going to look at number 13E for the first one, which was 5x squared minus 42x minus 27. It's really important that when you factor, you follow that factoring order of operations, which is first you look for and pull out a GCF if there is one. Then you look for special products, meaning the difference of squares and the PSTs. Then, if it's either x squared plus bx plus c or ax squared plus bx plus c is what will be left if it's not GCF or special products. These ones, you just do what multiplies to c and adds to b. Here, you have to do either the box or split the middle because it's what multiplies to a times c and adds to b. So this is the process you should be following. So when I look at E, first I check for a GCF. 5 is prime, and since these are not divisible by 5, there is no GCF. I know it's not a special product because I don't have perfect square roots on my first and last term. So that means that I have to go to step 3, and it's going to be this second type because there's an A value. So I'm looking for what multiplies to 5 times negative 27. 5 times negative 27 is negative 135. I want it to add then to negative 42. So negative 135 is a pretty big number, so most people may not know all the factors of 135 off the top of your head. So you might try a couple of them before you find the right combination. The right combination is 3 and negative 45. These multiply to negative 135, and they do add to negative 42. So that means that I either need to split the middle or use my box. So 5x squared, negative 27, and then these go in there with x's attached to them. So 3x and negative 45x. So now this row, I look for its GCF. They have an x in common. This row, they are both divisible by 9, and because the linear term is negative, I have to take out a negative 9. This column, I can take out a 5x, and this column, I can take out a 3. Do not take out a negative. You only take out negatives if the linear term is negative, meaning the one with the x attached. So this tells me that x minus 9 times 5x plus 3 is my correct factorization. Do not skip the check step. Foil it back out to make sure that it works. All right, the other one that I'm going to do is H, which is 12x squared plus 60x plus 75. On both G and H, there was a GCF, and I always get people who said, well, is it still okay if I didn't take it out? No, it's not, because it's not fully factored. It's only partly factored if you don't take out your GCF. So all three of these terms are divisible by 3, so I pull the 3 out. 3 times 4x squared is what would give me back 12x squared. 60x divided by 3 is 20x, so that's what goes here. 75 divided by 3 is 25. So when I pull out my GCF of 3, I'm left with this. After I do GCF, I look for special products. I know this can't be a difference of squares because it has 3 terms. I am looking to see if it could possibly be a PST because I have perfect square roots on both of these. The square root of 4x squared is 2x. The square root of 25 is 5. Remember, you have to check the middle term. 2x times 5 is 10, and when I double that, that does give me 20. So this is indeed a PST. I just went through my checklist, so that means don't forget to bring the 3 on the outside that was already there. Square root of the front goes in the front, 2x. Square root of the back goes in the back, 5. and then the sign of the middle term goes in the middle, plus. And so I am done with that. The next section is solving by factoring, so very similar to this, except that you actually have to find what x is equal to. Please don't try to solve for x on the ones that just say factor, because there is no equal sign. You can't solve for x. It's not an equation, it's just an expression. So make sure that you're paying attention to directions as far as that goes. On the solving by factoring, the first one is a box method. The second one is a PST, like what I just did. So I'm going to do 16D for my solving by factoring example here. You've got 27x squared minus 12 equals 0. Again, when you're solving by factoring, first you have to get it equal to 0, but after that, the order of operations is the same. Look for GCF, look for special products, and then finally do these as your last resort. So when I'm looking at this, GCF-wise, both 27x squared and negative 12 are divisible by 3. So I'm going to pull that 3 out. Gives me 9x squared minus 4 equals 0. Just because you've pulled a GCF out doesn't mean that you're done. If you're solving by factoring, you need to factor this further. So this is a difference of squares. They both have perfect square roots. It's subtraction between, so that factors into 3x plus 2 times 3x minus 2. And now, because it was a solve, that means I need to take each factor that has a variable, set it equal to 0, applying my zero product property, and then solve. So here I'm going to subtract the 2 first and then divide by 3. So that's how I got my negative 2/3. This one I would add the 2 first and then divide by 3. So that gives me positive 2/3. Make sure you remember to write your or between them. Next, we learned how to kind of do the backwards of solving by factoring, and that was if you had the roots, could you come up with the equations that they came from? So I'm going to do 17C here. The roots they gave you are x equals negative 7/5 and x equals 1/2. So remember, we're working backward here. We're saying if this is the answer, what equation did that come from? So remember, you have two options when these are fractional. The best one is to take the denominator and put that in front of the x, change the sign here, and do a plus 7. So 5x plus 7 equals 0 is the best way to do this. You could also do x plus 7/5 equals 0, but then again, you'll have fractions. Here, you should do 2x minus 1 equals 0. So if these were my solutions, that means these were the equations I had to have from the zero product property, which means if I work backward again, that their product has to equal 0. And so now my last step is just to FOIL that out. So first, 5x times 2x is 10x squared. Outsides, 5x times negative 1 is negative 5x. Insides, 7 times 2x is positive 14x. And then last, 7 times negative 1 is negative 7. So now, my only thing left to do is combine these like terms in the middle. So that's how I got 10x squared plus 9x minus 7 equals 0. Oops, I never boxed off the answer up here. A lot of people have a question on D. I'm not going to multiply it all out, but if there's only one root, you cannot just write x minus 6 equals 0 because that's not a quadratic equation. On 17D, you need to do x minus 6 times x minus 6 in order to come up with that answer. All right, next we went to quadratic inequalities. So I'm going to look at number 23 and going to look at part b. So 3x squared minus 7x minus 6 is greater than 0. So first thing, regardless of whether you're going to solve this graphically or algebraically, is you have to factor this. You have to find the x-intercepts. I factored it using guess and check. Most of you will probably do 3 times -6 and use the box to factor it. So that's fine. Either way, you should get the same answer, but it's 3x plus 2 times x minus 3, which means that my x-intercepts are at -2/3 when I set this one equal to 0. So subtract the 2, divide by 3. Over here, I would just add 3, so 3 is my other x-intercept. If you are solving these graphically, which is my preferred method, you do a sketch. You know that it crosses the x-axis at -2/3 and +3, which means it looks something like this. And then you say my original inequality was a greater than. So if I want to kind of squiggle in the parts that are greater than 0, it would be the arrows. And we said that whenever the answer is the arrows, that means that your final answer should be an or, meaning x is less than my smallest x-intercept, or x is greater than my largest x-intercept. Now, if you didn't like the graphing method, remember the other way to solve this is with a number line and picking points. So, if you were doing it that way, you would have to pick something that's less than -2/3. I would probably pick -1. And remember, you're plugging it into the original. So if I plug -1 in, 3 times -1 squared is 3. This would give me +7, which is 10, minus 6, which is 4. 4 is greater than 0, so this would be a yes. Between -2/3 and 3, I would probably pick 0, because 0 is easy to plug in. So 0 minus 6 is -6. -6 is not greater than 0, so that's a no. Picking something bigger than 3, I would probably just pick 4. So 4 squared is 16, times 3 is 48, minus 28. So that gives you 20, minus 6 gives you 14. 14 is greater than 0. So again, yes, no, yeses mean the same thing as shaded arrows. It means that it has to be an or. Remember that if it's the other way, if it's the loop or a no, yes, no, those answers turn into sandwiches, which is what you had on 23A. I do want to talk quickly about 23C. The reason that the answer is no solution is because graphically, it looks like this, and so there is no part of the original was a less than 0. There is no part of the parabola that is below the axis, so that means that there is no solution. If this had had an equals, then the solution would have been the place where it was 0, which is 8. But there is no equals here, so it only wants parts that are below the line. Algebraically, when you solve to get your x equals 8, that means that on your number line, you only have to pick 2 points, but you get no's on both of them, which again is why that there is no real solution. All right. Some people had a question on how to get from number 24 to number 25. In number 24, you had this, -16t squared plus 20t plus 6 is greater than or equal to 10. I got 24 because I subtracted the 10, which you need to get it in standard form, because that gets you 0, but then you have to get rid of that negative. You're not allowed to have a negative a in standard form. So I multiplied everything by -1, which changes all of the signs and also flips the symbol. So that is how I came up with that answer on 25. Number 26, just because it's a word problem doesn't mean we solve it differently. 26 you solve just like we solved 23. So you either do that graphically with the loop shaded, or you pick the test points. So 26 is the same thing as those. Next section, moving on to activity 8, simplifying our imaginary complex numbers. If you look at 1D is the one I'll do. It's 5 minus square root of negative 50. Because it's negative, you know that there's going to be an I, so I usually take that out first. You certainly can take it out at the end if you want, as long as you're not going to forget. But you can't leave radical 50 because it has perfect square factors. If you're doing the biggest perfect square method, you would just simply write that 50 is 25 times 2, and so therefore, square root of 25 is 5, so 5 radical 2. So I times 5 radical 2, remember that the I always comes after the whole numbers and before the radicals. If you're doing factor tree method, you might do, let's say, 10 and 5, 2 and 5. So again, you can see you get the same answer either way. These two have a date, so the 5 comes to the outside. So 5 minus 5I radical 2 is your answer. Plotting them in the coordinate plane, not going to go over that because the whole answer is on your answer sheet. Remember that the real axis, the left, right, and the imaginary axis is the up, down. Next, we did operations with imaginaries. So if you look at number 9, which was all addition or subtraction, probably the hardest one is D, so I'll do that one. It's probably the one most people would have questions on if they had some. So this is subtraction, which means anytime you have subtraction, your first step is to distribute the negative. So minus 7/3 minus 1/6 I. Now I need to identify and combine like terms. Here's negative 5 and negative 7/3. Those are like terms. You can actually combine those, but you need a common denominator. So my common denominator, right now this denominator is 1, so 3 is my common denominator. To get to 3, I would multiply by 3 on the bottom, so I multiply by 3 on the top. So negative 5, as many of you know, is negative 15/3. So negative 15/3 minus 7/3 gives me that negative 22/3 that you see in my answer. The second part, 4I minus 1/6 I. So you know the answer is going to have an I on it. You just now have to do 4, take away 1/6. Now you can do this one of two ways. If you don't like the common denominator method, which in this case would mean you convert this to 24/6, and 24 minus 1 is 23. So 23/6 I. You could also say that 4 minus 1/6 is 3 and 5/6, and then convert that to a mixed fraction by doing big times bottom plus the top. So 3 times 6 is 18 plus 5 is 23. So either way, you should get this for your answer. Next, we talked about how to FOIL. And in order to multiply, that's what you have to do on 10C and 10D. I'm not going to do that one because I'm going to show you the FOIL when we do 11D, but 10C and 10D, you need to FOIL it out, replace your I squared with negative 1, and then combine your like terms. I'm going to do 11D because it has multiplication and division in it. So it wants you to simplify 3 plus I over 3 minus I and write your answer in the form A plus BI. So division, the division part comes first here. We divide imaginaries by multiplying by the complex conjugate. So remember the complex conjugate, the real part stays the same. The imaginary part switches to the opposite. So I multiply by 3 plus I on the top and bottom. So Now I'm going to illustrate how to multiply them, which is by foiling. So I need to do that on both the top and the bottom. So on the top, FOIL it. 3 times 3 is 9. That's my firsts. Outsides, 3 times I is 3I. Insides, I times 3 is also 3I. And lasts, I times I is I squared. On the bottom, FOIL this out. 9 for my firsts. My outsides are 3I. My insides are negative 3I. And my lasts, negative I times I, is negative I squared. So FOIL. Then replace your I squared terms with negative 1. And simplify. So if this becomes a negative 1, that means I have 9 minus 1, which is 8. 3I plus 3I is 6I. On the bottom, if I squared is negative 1, I now have a minus negative 1, which turns into a plus 1. So 9 plus 1 is 10. 3I plus negative 3I is 0, so those happen to cancel out, which they should when you're doing multiplication of complex conjugates. And my final step here is to divide everything by 2 because they had a common factor. So 4 plus 3I over 5. Now, the reason why my answer doesn't look like that is because the directions said that we had to write our answer in the form a plus bi. So you need to separate the real part from the imaginary part. So the real part is 4 divided by 5. The imaginary part, 3 divided by 5 is 3/5, and then you've got your I. So now it's in the right form, a plus bi. And there we go. Next, we moved on to our other methods for solving quadratics. So again, just briefly pick a few here. So I'm going to look at solving by square roots on number 6. So the original was negative 2 times x minus 4 squared equals 16. So objective, get the squared term alone. So I need to get rid of this negative 2 by dividing. So I divide both sides by negative 2. That gives me x minus 4 squared equals negative 8. Now that my squared term is alone, I can square root both sides. So that gives me x minus 4 on the left. On the right, because of the negative, I get an I. And then the square root of 8 breaks down further because 8 is 4 times 2. 2 times 2. These guys have a date. So this radical 8 is really 2 radical 2. And so when I multiply that times the I get 2 radical 2. Remember that anytime we solve with square roots, I need plus or minus right after I take the square root. So now I've got x minus 4 equals plus or minus 2, and I forgot to write my I. I said it, but didn't write it. Plus or minus 2i radical 2. So then when I add 4, I can't add i's in plain numbers. That's why these are separated. So it just becomes 4 plus or minus 2i radical 2. All right, 12 and 13 are just finding the value that completes the square and factoring it as a PST. As far as the completing the square problems, I'm trying to figure out which one is the hardest, probably 17. So if we look, oh no, 18 is probably harder because it has an a value. So we'll look at 18 instead. So 2x squared plus 8x minus 7 equals 0. When we complete the square, our first step is to divide all terms by a. So divide everything by 2. That gives me x squared plus 4x minus 7 halves equals 0. After I divide all the terms by a, my next step is to put it into x squared plus bx equals c form. So I move the 7 halves to the other side by adding it. Then I set up my blanks so that I can complete the square. Remember that the value that completes the square is always b divided by 2 squared. So in this case, b is 4. So 4 divided by 2 is 2. 2 squared is 4. So now, factor the left as a PST. Square root of x squared is x. Square root of 4 is 2. Sine of the middle with a squared. On the right side, again, you can add those. You just need a common denominator. 4 is 8 halves. So 7 halves plus 8 halves gives me 15 halves. So now, it looks just like the problem that I had in 6. I've got a squared term alone, so now I can take the square root on both sides. As soon as I do that, I need the plus or minus on the right. And I'm going to give each of my radicals their own symbol. I look to see if I can simplify either radical. Square root of 15 doesn't come out evenly. And when I try to factor tree it, I get a 5 and a 3. Nobody has a date, so that means it can't simplify. Square root of 2 doesn't simplify either. I'm not done on the right side because I need to rationalize. I'm not allowed to leave a radical in the denominator of my fraction. So that gives me on the right side plus and minus radical 30 over radical 2 times radical 2 is a plane 2. So now my final step is just to subtract 2 from both sides. So that gives me x equals negative 2 plus or minus radical 30 over 2. So there's my completing the square. Almost done. I know it's been a long while if you've been watching this whole thing. Next we did the quadratic formula. So again, every quadratic formula is a little bit different. Depends on what type of roots you're going to have. I'm going to do, let's see, probably number 24. It would be the one most people had questions on. 24 is 42x squared plus 11x minus 20 equals 0. So that means that A is 42, B is 11, and C is negative 20. So opposite of b plus or minus the square root of b squared, which is 121, minus 4 times a, which is 42, times c, which is negative 20. Please make sure you bring the signs with them, all divided by 2 times a. So simplifying, negative 4 times 42 times negative 20 is 3,360. So I've got negative 11 plus or minus square root 121. Again, a negative times a negative was a positive, so it's a positive 3360, all over 84. So next, when I add these two together, that means that underneath the square root, I get 3481. That actually comes out evenly. When you get numbers that are really, really big, it pays to check to see if it's a perfect square first, because that is so much easier than trying to factor tree it and collect all your dates. This one happens to come out evenly, so that gives me negative 11 plus or minus 59 divided by 84. Remember, you can't leave it like this. These are all like terms. So I need to do negative 11 plus the 59, which is 48. So I've got 48 over 84, or negative 11 minus 59, which is negative 70 over 84. And now it's just a matter of reducing the fractions. So over here, this one reduces to 4/7, and this one over here reduces to negative 5/6. Here they were both divisible by 12. Here they were both divisible by 14. So x equals 4/7 or x equals negative 5/6. The very, very last thing that we did was the discriminant. So very important. I'm not going to recopy down here everything that was in that chart, but you need to know the chart that we did on page 146 in your book. The page 146 chart tells you what you need to know about the discriminant. If it is positive in a perfect square, 2 real solutions. If it's 0, 1 real solution. If it's positive but not a perfect square, there are 2 real but irrational. If it's less than 0, it's complex conjugates. So none of these examples is any easier than the other. They're all just working out the discriminant and then classifying it. So I guess I will do maybe 41 since it's the last problem. That feels like it'd be a good way to end the video with the very last problem. So this was the problem. Remember, the discriminant is just b squared minus 4ac. You're not doing the whole quadratic formula. So b squared is 144 minus 4 times 5 times negative 7. So that gives me 144 plus 140, which is 184. So my discriminant is 184, so I have to know my classifications. This is positive, and it is not a perfect square. So because it's positive, I know that there are going to be 2 reals. Because it's not a perfect square, that means that those are irrational, meaning there would be square roots. So 2 real irrationals was the answer there. Again, if there's still stuff you're struggling with, go back to old factoring videos if you need those. Go back through your book. There are a lot of very good examples that we worked through in there. Happy studying!